Hello guys, today we'll be looking into the tutorial 2, that is a half wave rectifier. So we are on the series of learning the software ltspice. We'll be taking a simple to the complex circuits to implement on the schematic of ltspice, and then learning what are the waveforms and what are the observation can be made from those waveforms and how to run this tool. So today's topic is half wave rectifier. So first of all, what do you understand by half wave rectifier? You need to be clear with the understanding and theory of half wave rectifier. It is a prerequisite, and then we'll be focusing on the practical implementation in the LTSpice. So what happens here is, let's understand this first, what is happening over here. You can see this is a simple circuit of a diode. So what happens here, when the supply voltage is supplied, when the diode is in forward bias condition during the positive half cycle. So this is the cycle that is supplied, sine wave or supply voltage wave, AC signal is applied, and what happens here, the diode over here is in a forward bias region, so we will get the output as such. DC output we are getting, right? You can see over here. And at the negative cycle, what happens, this diode act as in reverse bias condition for the negative half cycle. So this negative waveform of the output side is clipped off. So this is how we are getting the output at every positive half cycle. So that is why it is called as a half wave rectifier. I hope you understood this theory part of this. What is the half wave rectifier? And now quickly let's switch to the implementation part and see the waveforms. So this is your ltspice schematic window. We'll take a new schematic. We will build a circuit as I had shown in the diagram. Escape, take the resistor, click over here, escape, and we need one supply voltage. We'll write volt in the search command, and this is OK. And then we will apply a connectivity. Okay. And then it's done. Escape, take a ground. So here, pick a new diode, right, by clicking right, taking this diode, give the value as 1 kilo ohm, and OK. Supply voltage I am giving as 10, or very advanced, we will give a sine wave. DC offset is 0, amplitude may be 2, frequency may be 1 kilohertz. Okay. Then we'll run it. During this phase, what we will do, a transient run time we can give as a 10 milli or 20, and then okay. Looking at the input waveforms, so you can see that 2 is the amplitude we had given. So this is the sine pulse we got, and let's see at the output and the voltage at the output. So you can see that for the every negative half cycle, the output is clipped off, and this is how we got and generated the half wave rectifier, and also the amplitude is reduced. So how you will check it? On this voltage, you need to just click or left click. You will get this cursor. This is the cursor one, and you can take this, simply drag it over on the top. This is the one. So this from here you can see you will get the highest peak amplitude from the waveform. So this shows the horizontal value, that is this x-axis is millisecond, that is this much amount of millisecond what is the voltage you are getting. So that will be getting from the vertical measurement. And what is your vertical measurement over here? It is a y-axis. It is your output voltage waveform. So this is how exactly you can get the value that is required. This is the peak value, and the negative cycles are clipped off. So you can now, for exercise purpose, you can add one one capacitor over here that will be acting as a filter. What is the purpose of this capacitor? It will filter out the DC components, right? And change the value of resistor and see what happens at the output waveforms. Increase the value up till 10 kilo ohm and maybe reduce it to the 1 or 100 or some 100 ohms, right? So hope you understand this implementation of the half wave rectifier, and stay connected guys. We will be taking some more tutorials in the next session, and stay tuned. Do like, do share, and keep learning. Thank you so much.